All right, now that you've got your test statistic and your hypotheses written, we then need to talk about how we're going to make decisions using a p-value. So a p-value stands for a proportion. So you want to see what proportion your test statistic is coming up by random chance. So it measures how likely you are to get an observed test statistic by random chance, assuming that your null is true. So there's two different types of outcomes that we can have. We can have where your p-value is lesser ability. So if we're talking about how many dots are on or below, then that's going to give me the p-value to the left. So that's a percent to the left. This notation right here is actually more familiar. You'll see it again in college statistics. But essentially it's saying that your performance is less than what your observed value is, or your proportion is less than your observed value. If we're stating that an alternative hypothesis says the greater ability, then we're looking for how many dots are on or above. In order to calculate a p-value, you take the number of dots on or above or on or below, so I'm going to write dependent on alternative, and you divide that value by the total number of dots. So let's say that I've got 100 dots on a dot plot. It's not going to look like this. This is called a normal curve, but we are going to talk about normal curves in chapter 8. But essentially you're going to have dot plots that you're going to be looking at. And let's say that there's 100 dots on your dot plot, and our p-value falls within this region right here. And I count how many dots are on or below. Let's say there's 16, so 16 out of 100 would be my p-value. Okay, so here's an example using the Cardinals. Back to the Cardinals. I hope you guys love baseball. So again, we already talked about what our null hypothesis was and our alternative hypothesis was in the last lesson. But let's just write it one more time. So the Cardinals have the same ability to win at home and on the road. To win at home and on the road. And then for our alternative hypothesis, we want to see if they have a greater ability to win at home than when on the road. So Cardinals have a greater ability at home than on the road. Okay, so the home winning percentage was 6 out of 8. 6 out of 8 is 75%. The road winning percentage was 3 out of 8. 3 out of 8 was 37.5. And we subtracted those two values in order to find our test statistic. Again, you subtract based on your alternative hypothesis. So if you're stating a greater ability at home, that means we're doing home minus road. So that's 75% minus 37.5% for a test statistic of 37.5%. So since we're doing a greater ability, that means we're going to count the dots on and above. So count dots on and above. So I find 37.5% on my dot plot. Sometimes your dot plot on the bottom is going to have proportions. Sometimes it's going to have percentages. It just depends. But we can take 37.5% and make that a proportion by moving over the decimal place twice so that it's 0.375. So 0.375, usually if there's dots right here and it's kind of hard to tell, these dots are usually on the test statistic. So your best guess, nobody's going to count you wrong if you can't read a number line. Just kidding. Read a number line, right? But so count the dots on or above. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's 13 dots on or above. Your p-value divides by the total number of dots. So typically the example will tell you how many simulations occurred. So 13 divided by 100 is 13%. So your test statistic is 37.5%. Your p-value is 13%. And we can make a decision from that p-value based on that amount. So overall, in 13, again, bad line drawing. So in 13 out of 100 simulated seasons, the Cardinals had a difference in winning percentage of 37.5%. So the fraction 13 out of 100 is known as the approximate p-value. It estimates how likely we are to get a difference of at least 37.5 or 37.5 or more, assuming the Cardinals have the same ability.